The fourth simple machine is called an inclined plane, otherwise known as a ramp. It can move objects higher, or it can move objects to a lower place. It raises objects with less effort. The trade-off is less effort going through a longer distance and taking more time. Example of inclined planes are ramps, slides, and hills. The formula for inclined plane is the same as before. IMA is equal to the distance of the effort divided by the distance of the resistance. Since the object is being slid up a ramp, which is the slope of the ramp, that is the length or the distance of the effort. The resistance, if it's lifted directly upward, is in the vertical direction, so it is the height of the ramp, or h. AMA is still the same, FR over FE. The resistance force is the load or the weight of the object if lifted vertically. The effort force or the input force is parallel to the ramp. Pause the video, try this on your own, and then check your answer. A ramp height from the ground to the bottom of the building is 2 feet. Americans with Disabilities Act specification require a 1:12 or less ramp ratio slope. Sketch and annotate the inclined plane. So the inclined plane looks like a ramp. It has a height of 2 feet. This is my slope, or my L, and we know the ratio is 1:12. Using the ADA code, what is the allowable minimum length of the ramp's base? The base of the ramp is right here. This is my base. You learned slope in math as rise over run. We know that the slope is 1:12 ratio. That's going to be 1:12. We're looking for the run, which is the base, and we know the rise, which is the vertical height, is 2 feet, and this is the run. So solving for this, run is equal to 24.0 feet. In part C, it says using the known height and calculated base length, what is the length of the slope of the ramp? So we know this is the slope of the ramp. We know the height is 2 feet. We know the base is 24 feet. Since this is a ramp, this is a right triangle. So we're going to use the Pythagorean theorem, which is a squared plus b squared equals to c squared, which is the length of the slope. So a squared is the vertical height. That's going to be 2.0 feet squared plus the base, which is 24.0 feet squared, equals to c squared. So we need to square root both sides. Solving, c becomes 24.1 feet, and this is our L. Next, they want the IMA of the ramp. IMA of the ramp is the slope over the height, which is equal to L over H. We solved L as 24.1 feet. The height was 2.0 feet. Divided 2, you get 12.0. No units because it's a ratio. The units cancel out. In question E, it says if a person in a wheelchair has a combined weight of 185 pounds, what is the input force needed to travel up the ramp? AMA is equal to IMA. AMA is FR, which is the load or the resistance force, over FE, which is the effort force or the input force, equals to IMA. IMA we solved as 12.0 in the previous problem. FR is the resistance force or load given as 185 pounds divided by FE. So FE equals to 15.4 pounds. The fifth simple machine is a wedge. It pushes two objects apart or lifts objects up. It's pretty much two inclined planes that are placed together, so it looks like a triangular shaped object. The narrower the wedge, less effort force is required. The larger the split distance or lift, greater distance the wedge has to be pushed. Examples of a wedge is a knife, axe, teeth, and nails. If I look at the picture of the wedge, it does look like two inclined planes put together. If I split it in the middle, it is two separate inclined planes. The IMA for the wedge is the same as the inclined plane. It is the slope over the height. The slope here must be the distance that is always perpendicular to the height of the wedge. So in this case, it is the length based on the picture, and the height represents the thickness. The AMA is still force of resistance divided by the force of the effort. The effort force is always on top because you will be hammering the wedge down. So that is where the force is being inputted. The resistance force or the load going outward to split the object apart or lift the object up. Pause the video, try this problem on your own, and then check your answer. A hydraulic shear applies a 2,000-pound force to a wedge. It is used to shear plate steel to a rough size. The shear has a 1/4 inch thick cutting blade with a 45-degree slope. Sketch and label the wedge. So the shear looks something like this. So since this is at 45 degrees, this is a right triangle. When I draw my right triangle, if this angle is 45 degrees, this angle also has to be 45 degrees. If the shear has a length of 1/4 on one of the sides, then the other side must also be 1/4 inch because it's a 45, 45, 90-degree triangle. So that means this right here, this side is also 1/4 inch, and this side is also going to be 1/4 inch. So what is the length of the slope? So the slope, this side right here, this is my slope. So to find the slope, since this is a right triangle, we're going to use the Pythagorean theorem. A squared plus b squared equals to c squared. So this is going to be 1/4 squared plus 1/4 squared equals to c squared. Take the square root. So c is going to equal to 0.354 inch. So what is the ideal mechanical advantage of the wedge? IMA is equal to L. Remember, this is the distance perpendicular to the thickness over H, which is the thickness or the height. It's going to be 1/4 inch over 1/4 inch, IMA of 1. The last of the simple machine is the screw. It is an inclined plane that is wrapped around a cylinder. It can raise or lower things, hold objects together. The wider the thread, the harder to turn. It makes rotational motion into linear motion. Examples of these are lid, spiral staircase. On the right, you see a picture of the screw. The distance between each thread is a pitch. Usually the pitch is given in threads per inch. And to find the pitch, you have to take the reciprocal. That becomes 1 inch per 13 thread. And that will give you the distance of the pitch, or the distance between the thread. The IMA formula is the same as before. IMA is equal to distance of the effort over the distance of the resistance or the load. Distance of the effort is one rotation of the effort arm or the circumference. The distance of the resistance is the linear distance traveled during one rotation of the effort arm or the pitch. So DE becomes circumference, which is 2 pi r, and dr becomes pitch, which is p. AMA is the same as before. FR over FE is the resistance force over the effort force. The effort force in a screw is always rotational motion. The resistance force is always linear. Sometimes you will get the thread information such as 1/2 13 NC. 1/2 will tell you the diameter of your thread. 13 is the threads per inch to determine your pitch size. And NC is usually coarse or fine. Pause the video, try this problem on your own, and then check your answer. So we have a 7/16 screwdriver with a 1.5 inch diameter. Handle is used to install a 1/4 20 UNC bolt into a robotic arm. So first of all, we have a screwdriver. Looks like this. and this diameter here is going to be 1.5. Then we also have a bolt, and we know the diameter of the bolt, which is 1/4. So this is my diameter. This will give us the pitch because this is 20 threads per inch. So we have something like this. This is our bolt, and we have 20 threads per inch, and then we know the diameter is 1/4. So the first thing they want you to do is determine the circumference where the effort is applied. So the circumference is 2 pi r, or pi diameter. The effort is from the screwdriver, which is pi times 1.5 inch. This equals to 4.71 inch. C, they want you to determine the pitch of the screw. We know that it's 20 threads per inch. Pitch is going to be the reciprocal of that, so that's going to be 1/20 threads per inch. If I divide that out, this becomes 0.0500 inch. So the distance between each thread is 0.05 inch. So what is the IMA? IMA is equal to the circumference, which is 2 pi r over the pitch. Circumference we solved in part B as 4.71 inch. The pitch we solved in part C, which is 0.0500 inch. This equals to 94.2. No units because the units cancel out. In part E, ideally, how much force can be overcome if 5 pounds of force is exerted? So we know that AMA is equal to IMA. AMA is FR over FE. This is equal to IMA, which we solved with 94.2 in part D. FR is what we're looking for because it told you 5 pounds of force is exerted. Exerted means it's inputted. That's going to be 5 pounds equals to 94.2. So solving for this, FR becomes 471 pounds. When we put multiple simple machines together to complete a task, this is called a compound machine. To find the mechanical advantage of the compound machine, we find the mechanical advantage of each of the simple machines and multiply it together. So if we use 2 simple machines, we calculate for the first simple machine, then the second simple machine, and just multiply it. Efficiency is how useful your simple machine or compound machine is. It measures how much energy is lost due to vibration, sound, friction. In our ideal world, IMA should always be perfect and it should be greater than AMA. If your machine is perfect, the IMA will be 100% and your AMA will be 100%. So there will be no energy loss. So your efficiency will be 100%, but that is not possible. So in general, to find the percent efficiency is the work output divided by the work input times 100, or AMA divided by IMA times 100. The 6 simple machine, the formulas are pretty much all the same. IMA is the ideal. It is always distance of the effort divided by the distance of the resistance. You always measure and then calculate. You don't have to build anything. AMA, you must build and measure what actually happened. The formula is force of resistance divided by the effort force. All the formulas are the same for all 6 simple machines. However, for pulleys, you can also calculate IMA by the number of strands.